This is 1973, number 16. The number of bacteria in a culture. So I'm going to define a function, B of t. Let B of t equal the number of bacteria. But the number of bacteria is growing at a rate. Growing at a rate. Rate means derivative. So they're telling you the derivative of the number of bacteria is this. That's B prime. That's the rate at which bacteria is growing. They tell us that t equals 0, the number of bacteria is 7,500. So in other words, when t is 0, B is 7,500. And they want to know how many bacteria there are after 5 units of time. That's the question mark. So this is a classic fundamental theorem of calculus, because look, you have the rate and you have B at a certain point and you want it at 5. So this is what should start popping into your head. The integral of B prime of t from 0 to 5 by the fundamental theorem is B of 5 minus B of 0. So in other words, if you integrate the rate of B, it gives you the change in B. And here is why this is good. I know this value, 7,500. I can calculate this value, so I can solve for B of 5. So to summarize, B of 5 is B of 0 plus the integral from 0 to 5 of B prime of t dt. So to make this make sense, let's say B represented the number of blueberries you have eaten, okay? And they want to know how many blueberries you've eaten after 5 hours. Total. Yeah, after 5 hours, total number of blueberries that you've eaten. Well, first, you have to know how many you've eaten to begin with. And then if you integrate B prime, it tells you the change in the number of blueberries. So how many blueberries I ate from 0 to 5, plus the number of blueberries I ate before that, gives me the total number of blueberries at 5. So that's just kind of one example. So understanding integrating B prime gives you the change in B. So if I know my starting B and how much it changes, that gives me the ending. So you can get right to that without even doing this step here. That's where you need to get to eventually. So I'm just going to erase this to create some room. Delete that. And I'm going to move this higher to give me some room. And we will do this. All right, B of 0, I already know is 7,500. They told me. B prime is 3,000 e to the 2t over 5. So I'm going to factor out that 3,000. And then that is not t. I wish it were t, because if it were t, it would be easy. I'd be done. I am my own grandpa. But since it's not, I have to do a u sub. So let u be 2t over 5. That makes du 2/5 dt. And here's my question. Do I have 2/5 dt right there? And the answer is no, but I can get it. How do I get a 2/5 right there? By doing this. Now I have a 2/5. So that 5 over 2 is now there. And so this is e to the u du. This red part became u, and this became du. The 3,005 are out in front. I need to change the 0 and 5 into u's. So when t is 0, u is 0. That's easy. When t is 5, the 5's will cancel, leaving 2. So this becomes 2. And I'm on my way to getting the answer. This will be 5,000 if I simplify that, because the 2, wait, is that a 3 or 2? That's a 2. It's not 5,000. I'm a liar. That's 1.5, that's 7,500. I think, I hope. I'm doing this in my head. I think that's 7,500. Times, I plug in 2 e squared, I plug in 0, and I get that, which is 7,500 plus 7,500 e squared minus 1, which is 7,500 plus 7,500 e minus 7,500 because I distribute that. And these cancel, and I hope the answer is 7,500 e. 7,500 e. I don't see 7,500 e. I don't see, oh, e squared, I forgot the square. Okay, there's a square there. 7,500 e squared, is that there? There it is. Hopefully I didn't mess up. I think that's right.